Hello, everyone. I hope you can hear me. We are exactly at 8:05 East African time, and I'd like us to start so that we don't go over time. So today's speaker is called Ala. He's from Safe Buddha. Safe Buddha is one of our partners for the Google I/O event, which is going to be happening this Saturday. And all through the week, we're going to be having sessions, which will be part of the Google I/O pre-series. I want to thank everyone for making the time to attend. And I also want to thank Safe Buddha, especially for sponsoring us and for also gracing us with their technical lead, who will be doing an Android session on app modularization. In case you have any question as we proceed, please feel free to just type it on the chat, and we'll be taking questions at the end of the session. Along with me, we also have my colleague who's called Eugene. He's also going to be helping me. So welcome, Ala. Feel free to unmute and to also share your slides. Thank you.
Yeah, sure thing, Cynthia. I don't know if you can hear me correctly. Um, Let me know if you can hear me clearly. Can you hear me? Okay, perfect. Thank you so much for the intro. First of all, let me introduce myself. So my name is Ala. I've been doing Android app development for the past 6 years. Right now, I work as the mobile tech lead at Safe Buddha. I lead the Android and iOS team there. And in today's topic, we'll be talking about Android app modularization. What is like modularization, how to modularize an app, what are the benefits that we can obtain from this, and to give like an example on how you would architect your app in a way that's modular, and that would help you to deal with larger code base. Before we start, let us first talk about the growing code base problem. We've all encountered this, but with any project and in any code base, scalability, readability, and the code quality, they often decrease through time. This comes as a result of maybe like maintainers not taking active measures to enforce the structures and rules to make it maintainable. That introduced a lot of issues, modifications to that code base, adding features, will take time, will introduce conflicts to the code, and overall, having a code base that's not well structured and not well maintained will cause headache to developers, and even will decrease like the time of the development, increase the time of development, and actually make it harder for the developers to maintain the code base and add more features. Modularization comes here as a solution to avoid all of these issues, to make the code base scalable, readable, more scalable, and to maintain like a level of code quality across all features. So modularizing your code base helps you avoid all of these issues. So what is modularization? Basically, imagine you have a project, and that project has many features. So the old method and old way is to actually have all of these features laid out. You start adding features on top of each other, and eventually you reach a level where the code is very coupled and very hard to maintain. Modularization comes here to allow these features and allow that code to have reusability, to be reusable. So each feature you work on and each feature you add to your project can be reusable. For example, if you have, let's say you have two apps. Let's say you have, for example, a passenger app and a driver app. Let's say there's a business and you have, let's say, an app for agents, an app for customers. Having reusable features or reusable modules will allow you to have one source of code, one source of module that's shared across these two apps, and this module will be reusable across these two apps or even more than two apps. You can also have one of the main benefits is strict visibility control. And by strict visibility control is that each module will act as its own system, will be very obvious the purpose of this feature. Everything related to this feature will be encapsulated into that feature. And the third benefit would be customizable delivery. With a project that's fully modular, you have the benefit of delivering features based on countries, based on regions. You can have all of your features and modules delivered based on the needs of your customers and where your customers are located. Also, modularization offers many unique advantages. I'm gonna mention just five. So first and foremost is scalability. So once you modularize your code base, you will obtain one of the advantages that you will have a scalable code base. Now, with a scalable code base, there's no coupling between the modules and the features of the app, and you won't have, let's say, code that's very hard to maintain. A code that if you modify one line, you kind of like break 5, 6, 7 extra lines. You have like a very scalable code base that easy to maintain. You also have one of the unique advantages is ownership. With a larger project, you can have teams split on each module, and you can have ownership based on that feature. So, for example, let's say encapsulated in a way that you can have a team of engineers working on that module without having for the team to have knowledge of all the modules and all the features in your app, because each module is well encapsulated and each module serves a purpose for a business. So in that case, with minimal knowledge, you can have a team of engineers working on a feature or a module that would be this feature or this module would be easily like readable, and it will provide like clear understanding for anyone working on this. The fourth advantage is testability. As we all know, like a project that's not following like a modularized architecture, you kind of like reach a step where it's very hard to add tests to that project. But with testability and with modularity, you can have each module having its own unit and UI tests in a way where each module you can see like what is the percentage of the testing that has been done on that module. You can add tests on that module or that feature, and that would allow you to achieve like a good testing rate across all modules. And one of the last advantages also of the many advantages that we have is build time improvements. Having a project that's modular will allow you to utilize like Gradle functionalities to use incremental builds, building cache, or parallel build to enhance the build performance. So you can have all of your builds being built through Gradle at the same time. So in that case, you have faster builds, faster builds delivered to QA, faster builds, even to the engineers working on the project won't have issues like with building huge and very, very big projects that are not modularized. Now, how would we, so as we know, like, and as we will discuss even in this lecture here, modularization has many ways. There is no like one way to modularize a code base. So how would we judge like how good is a modular approach, for example? So here we can depend on three properties, and these properties are cohesion, coupling, and granularity. And we will be discussing in details what these three properties mean and how to judge a modular code base based on these three properties. Here by cohesion, I mean like a cohesion module is a module that acts, a cohesive module is a module that acts as its own system. Very clear, acts as its own system. Now with coupling, a loosely coupled module is a couple that if you modify or alter another module, then this module won't be affected by that module. And by granularity is a metric for measuring how many features you have on that project. So to discuss these three properties in details, let's look at the first and most basic modularization method, which is modularization by layer. So for example, in modularization by layer, here you can split the app into three main layers. You can have a data layer, a domain layer, and a presentation layer. The presentation layer will be the layer for the UIs and view models. The domain layer will be the layer that has all your use cases for the project, and the data layer has all of your repositories and data. Now, with this method, you have a clear separation of layers, and you can determine like which layer can access the other and which layer cannot. But the issue with this approach is you cannot just like reuse each of these modules. You cannot like just, let's say you have 2 apps, 3 apps, and these 2-3 apps have modules that are shared between them or features that are shared between them. You cannot just take the data module and domain module and kind of like include it into a different project. And the second main issue with this approach is each module will get crowded very easily. Even you did not like, even you followed like separated like your code into 3 layers, but eventually like while adding more features, you will have each layer will get very crowded easily, and they will become eventually harder to maintain. Now, if we want to look at this approach, then here we can see that let's judge this approach based on properties. So here we can see that this approach is very cohesive. So this approach, the data layer and domain layer and presentation layer, each layer act as a system on its own. So here we have cohesion, check. But let's look at the second property, which is coupling. So coupling, for example, here we can see that these architecture or this method of modularization, it's actually tightly coupled. In other words, if you modify the public interfaces of the domain layer, that will affect the presentation layer. If you modify the public interfaces of the data layer, then you will affect the domain layer. And in that way, then we don't have a check for the coupling. And of course, we won't have a check for the granularity because we cannot use these modules, and we don't have features kind of like separated each on its own. Now, so for this approach, we only had one check on the cohesion part, but for the coupling granularity, we didn't get a check for this. Now let's look at another approach. So another approach would be modularizing by feature. So modularizing by feature, here in modularizing by feature, sorry, just a minute. Yep, sorry for that. Let me share my screen again. Yeah, so here with modularization by feature, here you can see that here what we did is not only we had like just a data layer, domain layer, and presentation layer. Here we actually have here we have features. Each feature has its own presentation, and we kind of like separated each feature on by its own module. So the benefits of this, now each feature can be easily accessible. Each feature can be worked on by a team on its own, and you can even like reuse these features or modules into different apps. The only issue with this is the separation between layers is not the best. So you can access code from different layers. So here, if you want to judge this architecture based on the code that we have here, sorry, on the properties that we have here, so we can see that the modularization by feature is very cohesive. It's loosely coupled. We don't have issues with this, but it's not the granular. In other words, here, even with all of this approach, we don't have many features to work with. So why not use a mix of the two approaches? Why not mix the modularization by layer and modularization by features? So let's take a look here at an audiobook player architecture. So take a look here at an example. Let's say we have an audiobook player. So that audiobook player has three main features. So these three main features are home, reviews, and the player, which actually plays audiobooks. So for the data sources, here the data sources, we have books and we have reviews. So we have data for the books and we have data for the reviews. Here we can see that, for example, the player feature only depends on the books, which is like the source material for playing the audiobooks. While, for example, reviews should be displayed in the home. That's an example. Also, the reviews feature can depend on the book's data module. So with an architecture where you kind of like mix between the layered architecture and the featured architecture, mix between the two, here you can have each feature has its own data and has its own domain layer, and each of these layers are kind of like, here you can reuse the each module and each component. You can reuse it in a way based on the needs of your business. So an example like this, here we have two apps: an app for cars, Android Auto, and here we have an app for the mobile device. So here you can see for the Android Auto app, we only require the player feature. We don't require the home and the reviews because we wouldn't expect the customer or the user to be reading reviews or seeing the home of the app while driving, for example. So we only need the player feature, and this player feature only requires the data for books, data module, and this data module, of course, depends on the core network module. While on the Android app, we require the home and we require the reviews, and these two features have, for example, the books for data and the reviews. So how would we set up an architecture like this? How would we set up like a similar architecture? So the goal here is to achieve a project structure like this. Here I've kind of like assembled a very simple way to kind of like set up an architecture similar to the one demonstrated here in this graph. So here you can see we have the build logic. We have here the project of our own. The project has the app, core, data, domain, feature, and UI modules, and we will go into details into every module of that structure. So let's start first with the build logic. So here with a modular project, developers often face an issue where it's kind of like gets hard to maintain the build logic or the Gradle build logic for all the different modules that you have. So here we have multiple methods to kind of like have a centralized way centralized source where that build the Gradle logic is shared across all of these modules. And one of the most powerful tools that we can use, there are Gradle convention plugins. So Gradle convention plugins allow you to have one source of truth, one source of build logic that's a set of rules that's shared across all of these modules in a way that's maintained across all of these modules. So what are Gradle convention plugins? So Gradle convention plugins, they allow you to share common build configuration between the projects or modules that you have. They make it easier to maintain build configuration because with this approach, you have only one module that you need to modify. And once you modify the build configurations, they'll be modified across all the modules that are using that configuration. You can this also will improve the readability and maintainability of the build scripts because all the developers will have one place where they can see all the build configurations. They update it in one place. It will be that update will be actually reflected across all the modules, and that of course will make it easier for us to automate the build tasks for that project. So here, this is how we would set up the build logic module, have the convention, and have all the Gradle file inside of that module. Now, other than the build logic, here we have the data module and the app module. Here, the data module will handle the data structure for every feature that we have. So every feature will have a data module that's well separated and that offers data for that specific data structure that we have. An example here, a data module for books, a data module for reviews, etc., depending on the size of the project. The app module will handle just like the notifications, the drawer navigation, and basically like the link between all the different modules that should be present on that app, for example. The core module here, the core module is a generic module where it's like the core database, core model, and core networking and storage and utilities that are shared across all the modules. So rather than having to rewrite the code or to have duplications, you can have modules to have like generic methods and generic code for database handling, for reading and parsing models, for requests, how to read and receive requests and handle errors, for storing data, and utilities. Let's say you want to have core utilities for date and time, for example. And this core module will be utilized basically by multiple feature modules depending on each module needs. Now the feature module, the most important one. So this feature module will have modules of the features of your app, and these modules will be dynamic, of course. So for example, we have an authentication module. We have the player module, and we have the reviews module. So the player module will be only responsible for playing the audiobooks, reviews for displaying the reviews, and authentication for authenticating users. So each module will contain, will usually cover like the functionality of like a single screen or like a closely related group of screens. So doing this architecture, we would achieve something like this, where we have different features. Each features have they have data modules. These data modules are linked to these features, and here you have utilities or core networking modules, and then you can pick and choose between these features and have them like modularized between different apps. One of the tools that we also use and that benefit us a lot is actually Jetpack. So here Jetpack allow you to publish all of these modules and have Git branches for every module that you have. So imagine here you have, let's say, you have a module for authentication. So that authentication module will be shared across Jetpack and will maintain its own version control and version history, and you will just include it in any of your projects through like a simple implementation rules through Gradle. So Jetpack here is very important if you have like a very large project with different modules. For the modularization method at SafeBuddha, so here actually we follow the same architecture that I've mentioned, where we actually mix between a layered approach and a featured approach. And here we mix between these two approaches to eliminate all the disadvantages and to gain all the advantages. Here, as you can see, so at SafeBuddha, we have three apps. We have the driver app, we have the passenger app, and we have the partner app. So, for example, the authentication is a module that's shared across all of these three apps. It's maintained on Jetpack. It's modularized in a way where we can add flavors to it to kind of like customize it for every app that we have. And that's just one example. For every feature at SafeBuddha, it's actually modularized. We have over like 22 modules. All of these modules are shared across the three apps, and each module has its own Git repo. A team can go and work on that repository itself. Any updates to this, we can just increase the version number, modify it in the gradle properties, and then we would have the most recent version on the app. That's basically it for the modularization. Thank you so much for listening. Let me know if you have any questions. Thank you, guys. To answer your question, Kevin, I recommend you to check the Now in Android project. So the Now in Android project has all the docs on how to modularize a project, it's very clear. So I recommend you to start from there. Dev, can you elaborate more on your question about the modularization in it?
So maybe as Bendev elaborates on his question, we also have Kevin who is asking, how can one get to learn new modularization technique trends?
Yeah, can you hear me? I thought that I answered this question, but can you hear me now?
Yes, and we also had
Yeah,
you answering the question.
okay, perfect.
So we also have another question, which is how people can get to learn about new modularization techniques and trends.
I recommend to follow for learning the latest trends. Usually now in Android project, usually covers the latest recommendation by Google. You can also check Medium, for example, to follow all the devs, see how they're architecting their solutions, and how because each developer has his own way of modularizing the project.
All right, thank you for your responses. Does anyone else? Okay, so Scott has a comment. He's saying that maybe you can talk about the jailbreak protection Safe Buddha uses.
Yeah, sure thing. So for the jailbreak protection, so here with Android specifically, you need there are many ways that you need to check to prevent the app from being cloned, for example, from the source code to being cracked, and of course to check, for example, if a device is rooted or jailbroken. Here, of course, the first thing that I recommend is having signatures. So here you can have signatures that are kind of shared between the front end and back end, so between the mobile app and the backend servers. So for these signature that are kind of linked to the app package name, you prevent cloning the app, you prevent using the app in a way to, for example, do fraud. And then you can also check for the root and the jailbroken devices. We have the root beer library on GitHub that's very useful for this.
Thank you for your response. Bendev has given a follow-up for his question. So he says that they have a very large code base that has third-party applications, and one of the modules is used to detect if a phone is jailbroken, but some phones are genuine and are detected as simulators. So they still have the problem of unit tests, as this structure does not expose conducting tests in pre-bundled modules. Any thoughts on that?
Yeah,
Allah, if you
sure thing.
okay.
Yeah. So Dev, to answer your question, so yeah, I get your point. Not even so actually this issue is similar to one even if you want to detect locations. So usually with detecting fake locations, you might face issues where a location is being detected as like an accurate non-fake location, not emulated, while it's actually being emulated. Unfortunately, like with such approaches, you need like each approach has different solution. So you need to check. So each based on the architecture and the code base, you might need to add extra handling to prevent that from happening. But there's no one solution that fits all issues for this. I recommend you to look at the root beer library. I'm going to share the link here on GitHub, so you can take a look at this library, see if it helps you. To answer your question, Joseph, about the Android app, now in Android project being difficult, you can start by, for example, learning it step by step. So you can start by looking at GitHub, at all the open source projects on GitHub, and try to look for a project that's modularized by layer. And then you can start looking at the project that's modularized by feature. If you're also new to this, you can even like take a step backward and look at the normal architectures. So as you know, we have architectures like MVP, MVVM, MVC, or MVI. You can learn about these architectures, see how they are implemented. You can, for example, go to GitHub and search, for example, MVVM, for example, the model view model architecture. You can look at the projects that are following the MVVM architecture. And then after learning this, you can start looking for projects that are using the modularization by layer, for example, where you use the MVVM, but you have 3 layers, like the data, domain, and presentation layer. And then you can move upward and learn about the modularization by feature. And then you can, then when you open the Now in Android project, you will see that it will become easier for you. But yeah, if you don't have experience with all of that I've mentioned, Now in Android will be like will be hard for you to start with.
Thank you for your response. I've also shared the link on the chat, which is a resource that Allah has also shared with us. I'll be taking the last 2 questions. So we have a question from Liam, who is asking, could you share any resources to learn ADB commands for accessing Android or ADB supported devices?
I don't have a resource for this. Usually, this is something that I've learned through like the Android docs, Stack Overflow. So it's one of the things where I haven't encountered a book that covers all of these. You kind of like learn this by gathering info from different sites to be able to learn this. Also, to elaborate on Ben's question, one of the things that I find very useful are the books by Corico. I've shared the link here. So these books are very high quality, and they have books on Compose. They have books on architectures, clean architectures. So they're a very good start for beginners if they want to learn about this.
All right. Thank you for your response. And our last question is going to be from Ben, who's asking you to share with us how you do SSL pinning on your platform and share the best practices if possible.
For SSL pinning, Ben, we use the normal Android network configuration for doing that. I can share with you an article to provide more info on this.
All right. Thank you for that. I'm afraid we are now finishing up. You can share a link in case you have a link on the SSL pinning question.
Yeah, I've shared it with you.
All right. Let me also share the same. I've also shared the same on the
Liam,
chat.
to answer your question, you can reach me on LinkedIn or Threads, or even email. Let me actually provide my email here. So if you have any question, feel free to reach me out. I'll be more than happy to help.
Okay. I've shared Allah's email on the chat for anyone who might want to continue the conversation. We've come to the end of our session for today. Our next speaker will not be available to join us, but she's going to join us later on in the week. So first of all, I'd really like to thank Allah for joining us and for availing his time. I know he's a very busy man as a tech lead of Safe Buddha. So we really want to thank you for your session and for also providing your email as a follow-up to anyone who wants to continue the conversation. I'd also really like to thank Safe Buddha, who are our sponsors and partners for Google I/O Extended this year, and they've really supported us. And then finally, I'd like to thank our audience for joining us on a Monday evening, probably after work or school. Thank you very much. This session is streamed, which means that after this, you can also still watch, and you can also contact Allah in case you have follow-up questions. And lastly, I'd like to thank the GDG Nairobi team for hosting this. We'll be doing this every night up until Thursday as part of our Google I/O pre-series. Tomorrow we're going to be having the AI session. And then on Wednesday, we're going to be having cloud sessions. And finally, on Thursday, we are going to be having web sessions. So feel free to also attend those. Yeah, so it's a wrap. Have a lovely night. And thank you very much. Bye-bye.